Okay, I think we're about ready to begin. I think the seating has sorted itself out. I'd like to welcome you. I'm Peter Nurksey, and I'm from Sun Microsystems and with Jeannie Trikel, also of Sun. We've had a computer history talk series for the last 5 years. Our very first program 5 years ago, back in April 1993, was right here in this auditorium on early computing at Livermore, and the total number of people present, including the speakers and the entire audience, was 20. But this was a very distinguished audience, because right there in the front row, and 2 seats in the center, we had Gordon Bell and Donald Knuth sitting side by side, sort of like hardware and software together. So we've had 5 years of programs. Since then, in the last couple of years, we've joined forces with the Computer Museum History Center at Moffett Field, which has world's largest collection of computer hardware, over 100 tons of computer hardware. I might say that our second program, after that distinguished first program, was on the 20th birthday of the Ethernet back in May of 1993. Again, a PARC occasion, although we held it at Sun, that program. And John Schock was one of the speakers who also suggested this program here tonight. And since then, looking back over our programs, I find a couple more particularly relevant to this evening just last fall. Like October 28th, we had a program on the early user interface design at Apple with Larry Tesler and Chris Espinosa, which directly drew on a lot of the work done at PARC and that you'll see in the STAR user interface this evening. And our November program last year, that was on Doug Engelbart and his writing on augmenting human intellect. And there we had Bill English, who worked with Doug on early input devices, and he had a whole series of early mice that he pulled out of his briefcase, one after the other. You know, some were plastic, some were wood, some were metal. A whole profusion of early mice, which you also see in the STAR user interface. And remember, the STAR comes from 1982, but just that recently, 1982, people weren't sure how to describe a mouse. It was a digital pointing device. They didn't have any better words for it. Now, about the program tonight, obviously the main center of interest is the STAR itself, or there's 2 stars running, just in case one falters. I'd like to make a point about the hardware. In my announcement, I wrote how Dave Kerbo from Sun had like 12 stars, from which he was making 1 or 2 run. But those were a later model of the STAR. We were lucky enough for this program tonight to have the original STAR, the Xerox 8010, running. And we're even luckier that we have the original software running on it. And the code to activate the software was only found by Bob Garner 2 weeks ago. So there, I think I've said enough about the series. And, well, there's the main topic of the program, the STAR. So I'll ask Dave Liddell to speak now. And Dave directed the STAR development effort at Xerox.
Thank you, Peter.
Probably need to change monitors. Yeah, that's right. Everything but the same. Okay, thank you.
How's that? Not that I couldn't make the place resonate entirely unamplified, of course. There's something very painful about this experience to me, which is that I'm seeing all these people that I haven't seen for many years, and you are unchanged except for a little pigment here and there. And recognizing that that was going to be true, I promised myself that I was not going to name names in my discussion, precisely because I'd have to leave people out, and I can't bring myself to do that. So I will name really only one prominent name in the course of what I'm going to tell you about. But I want you to know that I'm just going to try to set the context, and it is a considerable and complicated one, for the development of STAR before my talented colleagues who really did the hard work tell you what we did and how we got there. But I'm going to just try and help you to understand really what that world was like, the one in which Xerox decided to participate in these new industries and in which and for which we developed the STAR and the related network services and so on. There's been a wonderful, what do you call it? When there's more than two people in a dialogue, is it a polylog or a multilog or something? Anyway, there's been actually more like a cacophony of email discussion about all the firsts and inventions and new ideas and whether they were or weren't new or for the first time. But it's really been invigorating. And so a lot of us had an opportunity to participate in that. I'm not going to try and identify those things, but some of you may pick them out as we go along a little bit later. But first of all, I want to talk about PARC. Not this PARC that we're in now at all. The same location for part of the time. But this has nothing to do with Xerox Palo Alto Research Center as it operates today, but just a very small window of its long and glorious history from 1970 to 1975, roughly. Of course, I'm only going to talk very briefly about issues directly tied to certain kinds of information processing and computing problems. But having said that, I want to mention some very strong major high points that affected a great deal of what we did. First of all, there was a famous talk given by C. Peter McCullough, who was then the much respected chairman and CEO of Xerox. And in this famous and much publicized talk, he said that he wanted for the future for Xerox to be the architects of information. This was a great phrase because nobody knew exactly what it meant. And there were quite a few interesting things that you could do and simply cite that as the justification. But it also made Wall Street feel a good deal better about Xerox's future prospects to realize that they weren't just focusing on sort of reprographic copying and duplicating and so on. There was already the early work that had been done by Gary Starkweather and others leading to this thing that we then called SLOT, the Scanned Laser Output Terminal, which grew up to be laser printing of the kind we know today. And this was very cool because we really could print very, very interesting documents with it. But it was really hell to produce those documents at that time. There was a splendid project called Polos, the PARC Online Office System. I came there first to work mostly on that project and to help out with the Learning Research Group a little bit. And the really nice thing about this was for the first time we saw how very, very attractive office equipment designed for professional users rather than for clerical users could be. High resolution displays with beautiful, carefully rendered fonts, pointing with a mouse and having a really quality keyboard and so on, and the ability to print the kinds of documents that otherwise we had to get a paper accepted by a publication ever to see our words rendered so beautifully. And now, even if it was entire rubbish, we could see it rendered beautifully in these wonderful fonts and so on. There was a great deal of work at that time, sort of very turgid, interesting work going on in the Learning Research Group, which among other things led to small talk in a somewhat different way of thinking about using screen real estate as well as programming. And in 1973, the Alto and the Ethernet independently were invented, but they began to work together relatively soon thereafter. The Alto back then was a prototype for a pad-sized computer, and Chuck Thacker promised us that it would only take a few years before it went from being a featureless cube 30 inches on the side to being this pad-type computer. The functionality of it, though, was very much what was wanted. There was a lot of other creative ferment going on. I won't bore you with the details, but we had people interested in networking and protocols and various programming techniques and very advanced notions in operating system security and memory protection and other things. In the midst of all this, in January of 1975, my friend and principal mentor, Harold Hall, stepped up and agreed to start an activity to try to harvest these ideas into a long-term architecture for Xerox's entry into the new world of the automated office. So he was the one willing to face up to the corporation's sort of mixed and tentative interest in doing this and saying, no, we can do it. Palo Alto is a place where we can get started and put together that story in an understandable way and harness some of these good ideas that have already been developed here in PARC. Now, between 1975 and 1980, the time period of interest when all of the development was being done, things were very different than they are today. You can't extrapolate backwards from where we are now and get there, okay? There's been a very big discontinuity in many dimensions that's occurred since that time. But mini computers were all the rage. If you couldn't do it with a mini computer, it probably wasn't worth doing, was what most of industry thought. And even IBM had begun to package things into mini computer-sized chunks for various sorts of reasons. But the very interesting and cutting-edge companies were the mini computer companies at that time. And the idea of the interaction devices that were going to be in front of the users was that they were going to go from being dumb terminals, which at that time still predominantly were teletypes and paper-based terminals. It was a great luxury in that world to have an actual screen on your terminal. And there were a few intelligent terminals. Intelligence, of course, being a relative term, but it did mean that some of them had a little bit of memory and could be made to do mildly interesting sort of quasi-computational things. But the hot ticket in those days was electromechanical word processing, or clickety-bang word processing, as we used to call it back then. IBM was the big lion in this marketplace, and it was one hell of a big business, and they were also challenged by various other people. By the way, if you don't know this, the term word processing was made up by the IBM Deutschland engineering group in Germany to be sort of a parallel with data processing. I'd love to know what that German word for word processing was. I'm sure it's a real tour de force of sort of linguistic construction. But in any case, this was then a big business. But it meant, in general, a typewriter imbued with a modest amount of storage and logic. And you could somewhat painfully edit a document, save it onto a magnetic tape or a little card. This was a very big business. The big threat at that time to IBM's dominance in this business was Xerox, with a division in Dallas, which, because they possessed a daisy wheel printer from Diablo across the bay, a company Xerox had bought, had actually introduced quite a nice high-performance electromechanical standalone word processor. There was no independent software industry. Software was written by the customers, say Bank of America or someone like that, or by the vendor of a mainframe, but not by anyone else. If you ever wonder where the I in ISV comes from, when the first companies finally started writing software, companies that weren't part of a mainframe company, this was so shocking that a new category was made up, and they were called ISVs. But there was no such thing during this period of time. The future of office systems was imagined by the pundits of that time to be entire turnkey closed vendor office systems. Burroughs had one, Wang had one. Everybody was sort of hovering around this idea of the marketplace. And in particular, there was no personal computer industry whatsoever. Near the end of this era, a few personal computers appeared, as you know, kits, and then the Apple completed packages, and then a few others. But there was no really strong industry. It was essentially a hobbyist business at that time. Inside Xerox, this is very important to understand. That is, this was the climate in which we operated in this period from 1975 to 1980. Xerox had entered and then exited the computer business. That is, they had bought the leading mini-computer company of the time, Scientific Data Systems, which was a competitor with Digital. And at the time they bought it, it produced primarily real-time, shared, very high-quality mini-computer systems. During the era that it was a part of the Xerox Corporation, it made a turn in the direction of providing business data processing systems. So the Sigma series began to be sold competitively against IBM rather than, for instance, competitively against Digital, as had the 930 and 940 and other famous systems been sold. This turned out to be a very tough business to participate in. And in 1975, Xerox somewhat painfully left this business, selling its remaining interests to Honeywell. But leaving behind, luckily for us, a large number of really talented people in El Segundo, a very strong capability in electronics and certain kinds of system software and a factory, and gave us suddenly sort of a base, a place in which this kind of work could be done. Xerox at that time was by far the largest vendor in the facsimile business. But Xerox was by the middle of this era, a $5 or $6 billion company, and the fax business was a very small, few $100 million business, and not very digital in its nature. The fax business we know today was almost completely restarted from scratch by the revolution in digital logic. Xerox had gone from really dominating the copier and duplicator world to suddenly being under a great deal of very stiff competition from very, very tough competitors, including Kodak and IBM and Ricoh and Canon. And some of Xerox's longtime patent protection had expired. Somewhat worse than that was Xerox had to agree to an IBM-like consent decree with the Justice Department, limiting a number of things that it could do, both as to pricing, but also as to competitive statements it was able to make in the marketplace and so on. So suddenly we had to go to this very sort of Marquis of Queensberry, dignified, uncompetitive behavior in the sales force, which was not an easy adjustment for the company to make at that time. We had a word processing operation largely in Dallas, as I had mentioned. It was troubled. They had a hard time bringing it to profitability. They had a hard time focusing it down as a business, and there was much energy going into what will we do to fix that operation. The printing systems division, which by the end of this era had begun to build laser printers based on much of the work done here in PARC, particularly work that used very clever character generation technology and other things. It was very focused on selling computer printers to MIS departments. That is, big, really beautiful printers that were hooked up to great big mainframes and produced 2 pages per second of very high quality output. That was the business that we were in, not anything to do with casual office laser printing and so on. And at this time, Xerox was the perhaps number 2 or 3 largest participant in magnetic storage. They owned Shugart, which pretty much owned the floppy disk business and had a very strong position in the sort of Winchester disk business, and they owned Century Data Systems, one of the big players in packaged disk drives. So there were a lot of things that were true of Xerox at that time, and many problems to be worked on or itches to be scratched then that simply don't exist now. This list of stuff that I'm showing you here that was the big deal. Those were the things that we were actually focusing on and that were affecting our choices about what businesses we were going to be in. Ever heard of any of them before? I doubt it. Now, when we started this organization, we moved around Xerox a lot. In 1975, Harold Hall and I, and then Gail Tafani, and then a small growing group of other people, were part of the Information Technology Group's OIS project. By 1976, a, quote, division had been started, although it wasn't really the size of a typical division, called the System Development Division. By 1978, it had been shuffled to be put together with some other loosely information-related products in order vainly to try to hold on to one particularly self-centered executive who, after they reorganized the corporation to keep him, wound up leaving to run Amdahl anyway. And then in 1980, we were kind of snatched from the jaws of death by Don Massaro, who still thought it was a good idea even though other people didn't, and that it deserved to go to, in some way, to see the light of day. And so we were lashed together with the Dallas Office Products Division, and were able finally to get our products built and into the marketplace. It was a case where the product and the ideas were so strong that even though we never could quite have a good home for them, it's also true that no one wanted to stop them in their tracks because they had an obvious merit and an obvious value, even though they were an imperfect match with most of the business objectives of the corporation. What were we supposed to be trying to do? We were trying to do an overall system architecture that would last 10 years, with its first implementation being to support electronic copying and printing. And then for professionals who were doing document creation and transmission and storage and so on. And then finally, as a long-term overall successor business, when people would no longer be allowed to cut down trees and there wouldn't be a paper-based office automation industry anymore. In 1975, at Harold Hall's urging, I wrote a document called the OIS Architecture. This described these essentially 7 points. There was more detail, of course, but I won't put you through all that. The main point, though, is in the parentheses, you see what the ultimate implementation was that we finally did of these particular points that were in this architectural document. That, with some pain, we got people to agree was a good long-term approach for us to take. So the idea was we'd have a packet-oriented local area network. We had already had the 3 megabit Ethernet as its inspiration. This was to be named the Xerox wire, and eventually we renamed it the Ethernet because that was a better name. No one used the term client server back then, but on the ARPANET there was the concept of user and server. Everything was hosts, of course, but you had a using host with a bunch of terminals and a serving host. And we worked out the way to have that host be a workstation belonging to one person, i.e. a client as it's now called, and of course a structure of a number of servers and server protocols. A scalable CPU architecture in the old sense of the word architecture. Now that there are so many people who do architecture that don't know very much about it, we talk about architecture as if it were design, like the way it is in a building. But in those days, architecture meant not how the box is put together. That's what it did not mean. It meant everything but that, namely the instruction set and the things that happened when you executed them, no matter how you put the box together, no matter what the underlying technology was or how big or small any register was or anything like that. It was the implementation-independent design, which we did in a document called the Principles of Operation. We also, operating system research had just begun to go from the Baroque to the Rococo at this time. And we managed to avoid the worst excesses of operating system design. But we did design a very, very modern operating system and quite sophisticated for its day. Now, the fact that the VM in there stands for virtual memory shows you what the world was like back then, and that memory was still relatively scarce, even though we were thought to be the most reckless and profligate people in the world for having 512K bytes when we went out the door. Whew. And when you hear people talking about 192K machines, those were 16-bit words, and we couldn't quite get it in 192K, but I didn't let the pressure off until the last minute, fearing that it would get even bigger. The development environment at that time was also a modern and sophisticated one that we were very proud of and was clearly far ahead of what had been done up until that time. Bear in mind that I'm not naming any of the things that happened after this time. I'm just talking about the stuff that we described in 1975 and shipped by 1981. The servers that were out there were print and file and mail and what today we would sort of call some combination of routers and bridges and gateways, our communication server stuff, including internetworking. And then finally, this idea of the STAR, the 8010 professional workstation. Why the STAR itself? Why particularly that last piece? Here's what we were trying to do. I tell you this to put in context what you are going to see demonstrated. At this time, we were really trying to make the first product that professional users would actually like, because it added more to their life than just giving them a way to get memos typed and so on. And in particular, we wanted to overcome the idea that this was somehow an unacceptable thing for professionals to do by making a really usable and really powerful workstation. Naturally, what we hoped they would then do was to create these elaborate kind of self-serving documents like we did in PARC. We had some beautiful typesetting for equations, for example, because if you got people to typeset their equations, then you knew for sure they couldn't print this on anything but one of our laser printers. And that was the whole idea. We wanted to induce people to produce subtle and elaborate documents that would then favor our ability to make money by storing and managing and printing them. And finally, we wanted the brand name Xerox not to just be in the copier rooms and seen by purchasing agents and people who were responsible for duplication. We wanted to get it onto the desks of management in the Fortune 500. So these are the things that we were trying to do at this time. This is what the star was about. And now Bob Belleville and Bob Garner are going to tell you in more detail about the hardware design aspects of the star. I switched to B, is that good?
Personal interactive software like STAR was unknown outside the research facilities in 1978, the year Dandelion was started. Apple Macintosh began to catch up, perhaps, to STAR's capability about a decade later. Microsoft Windows took almost 15 years. Inside Xerox PARC, however, we were quite used to this level of creature comfort. At SDD, a Xerox product group spiritually attached to PARC, almost everybody had an Alto. First built here at PARC in 1973, Altos furnished most of the computational horsepower for our culture. We had email and FTP all over the world via the ARPANET, computer-aided impressive office automation and software development tools, and computer-aided design facilities that took us from schematic to prototype nearly automatically. Our mission at SDD was to take some or all of this to the world, except we were going to redo it all from scratch. Alto was mature, and there were about 1,000 machines in use in 1979. Basically a 16-bit machine, Alto had a 600 by 800 pixel monochrome display arranged vertically like a sheet of paper, a 3 megabit Ethernet, a removable hard disk, and up to 512 bytes of RAM. Alto was implemented in small and medium scale TTL logic. The CPU was microcoded, and all micro instructions were completed in 170 nanoseconds clock cycle. That's about 6 megahertz. Main memory cycles were about 1 microsecond, and by running 32 bits wide, that gives a total memory bandwidth of 32 million bits per second. In addition to emulating various instruction sets, microcode in the Alto was also used to implement much of each peripheral controller. The hard disk controller had, for example, only a 16-bit word buffer. Since in those days disk data rates were 1.5 million bits per second, microcode could leisurely read this buffer once every 10 microseconds, and small buffers meant low cost. STAR was to be a much more powerful workstation. STAR's display was to be 1024 by 800 pixels, some 2 pages compared to the Alto, and consume 51 megabits of memory bandwidth. Included too was a 10 megabit Ethernet, up from 3, and 10 megabit disk drive. In addition, STAR's application software with overlapping windows and multiple fonts, and the Pilot multitasking virtual memory operating system were both written in Mesa, and they were to be emulated by this same processor at the same time. Alto, in short, wasn't nearly fast enough. I had studied our situation for my boss, Bob Metcalf, one afternoon and was talking with him one afternoon in 1978. I was lamenting the problems we faced for STAR to build such a piece of hardware that would support such a thing. Bob's mind was wandering in the way it did when he'd already gotten the point. But he looked at me suddenly and said, "So what are you going to do about it? Just sit here and whine?" STD had no charter to do processor hardware. The last machine I'd personally designed was my homebrew 8080 in 1976, and I was at the very bottom of the STD org chart. My coworkers, Roy Ogus, Ron Crane, and Robert Garner, were working on the new 10 megabit Ethernet. Robert had heard tell that Butler Lamson had sketched out the design of a new kind of CPU on 7 sheets of yellow paper. Butler's idea would make it possible to build a high-speed machine with relatively small I/O controllers. Alto had been based on the 74181 accumulator chip. Butler's design, which was later called Wildflower, because they were expected to come up everywhere, used 4 2901 4-bit CPU slices. He had a preliminary data sheet from National Semiconductor which convinced him that the machine could be built with 100 nanosecond cycle time and a 300 nanosecond memory cycle. That would be a 10 megabit machine. Best of all, Wildflower's design could guarantee memory latency for I/O controllers and get us the speed we wanted with Alto's simplicity and low cost. The genius, really, of Butler's design was the concept was to synchronize the scheduling of microinstructions not only with the main memory, but also with peripheral controller microcode. Microprocessor tasks were scheduled in 3 instruction groups called clicks, and each click, microcode had exactly 3 microinstructions and 1 memory access. Clicks were arranged into a round with each click, which each controller able to demand only a fixed number of clicks. In Dandelion's case, there were 3 clicks per round, 5 clicks per round. The disk controller had 1 click per round assigned, so the hardware for the controller could be designed knowing that 1 memory access was available every 15 clocks. Clicks not required by the controllers were given to the Mesa interpreter. The scheme gave low-cost controllers, DMA, microcode-based virtual memory, and complete flexibility for the design of Mesa's byte-coded instruction set. Another way of looking at Wildflower's architecture is that the CPU acts like the system bus in modern machines. One addition we made to Butler's design was the addition of an Intel 8085, which we kind of snuck in the side. And it was to manage all the low-speed I/O, such as keyboard, mouse, serial communication, floppy disk, and real-time clock. The 8085 also took care of the job of initializing the main CPU to put it into operation so that we didn't have to have a huge amount of logic to support that function. So as a result, we ended up with an early dual processor system. Both Bob Metcalf and Dave Liddell were ready to be behind us on this adventure, but they needed a document and lots of slides to support our claim that we were doing the right thing. And to reinforce what Dave's just been talking about, this is the environment, the same period of environment he's talking about, and the kind of, as Dave was saying, no possible way of projecting this, interpreting this back from the current environment. In those days, things were very simple. Microprocessor technology was not in the state that it is now by any stretch of the imagination, and the personal computer, as I say up there, was hardly such an animal. Clearly, our only choice to achieve STAR was a custom processor. Dandelion was an order of magnitude beyond anything currently available or envisioned for the near future. By the way, we picked the name Dandelion because PARC had been picking project names after very aggressive beasts. Notice the aggressive beast hidden at the end of a common wildflower. Dandelion's inception came at the end of the bipolar era. Motorola 68000 was introduced the next year in 1979 and signaled the end of bipolar machines. CMOS speeds and densities grew very quickly from then on. Dandelion shipped in 1981, the same year as the introduction of the IBM PC. The Apple Macintosh, the one that shipped in 1984, was also started that same year using the 68000 as its CPU. The team on Dandelion, and I'm going to actually put up a slide while Robert Garner is coming up to show the people that were involved in the very earliest part of that design. They were a very remarkable group. Our challenge was to have a picture on the screen by Christmas of 1979. This was accomplished by feeding the output of a scanner into memory. Between 1978 and 1981, while the workstation was moved into production, the design was enhanced to support file servers and print servers. So here's a look at the people, and we'll get Bob Garner to come up and show some of these wonderful pieces of hardware here.
Now, I think actually many of the people on this list are here. This feels a bit like a reunion. For me, it's been going back and reawakening parts of my brain that I thought were gone a long time ago. It's been quite an experience. So thanks, Bob, for that introduction. I'm going to do a little hardware show and tell. And I'm going to try to set some context as well. You heard from Dave Liddell how this was an era of machines that are totally different from what we know today. And so I found some old slides in an old box and had them scanned in, and I'll show you up here to give you a little bit of a feeling for what the context was like. Now, one of the, I think it was Gordon Bell who noticed, who remarked many years ago that the design of a machine is based not only on its architecture, but also on the financial and the cultural aspects of the organization that builds it. And this was nowhere else true than here at Xerox. And at the time, well, actually today, a very powerful computer fits in our pocket. You know, my 10-year-old understands that. But in the mid-1970s, a computer of comparable performance, you know, if you inadvertently bumped into this thing, you would smash your nose. So, you know, what today fits in your pocket looked like this in the mid-1970s. And these were the real computers. These were the ones that we were all supposed to aspire to and build, you know, coming out of school. Not these little things you can put in your pocket today. So this was a much-loved machine, the PDP-10, 36-bit machine, a little under 2 MIPS in performance. What I like about all this is everyone now knows these terms. And about a megaword of memory, not a megawatt of power, but about a megaword of memory. A very much loved machine. The designers of the Star software would have loved to have had hardware of this power, but the technology wasn't quite there. Now, a machine that was a little closer was the PDP-11. This is the Model 60. It was a 16-bit machine with a little more than half a MIP of performance and a 1/4 megabyte of main memory. And it turns out these features were almost precisely what the Star designers were looking for in performance. Now, the only side effect is that it's not going to fit under your desk, obviously. So something had to be done. Notice Dave referred to the two very sexy I/O devices on the side there, the terminal, the character terminal, and your own personal printer. So this is kind of what we wanted, but still it was a little too big. So what made the Star hardware unique? Bob talked a lot about this. Really, it was based on the Alto. The designers here at PARC on the Alto realized that really what they were designing was, in essence, an appliance. I called it an office appliance here. You know, these days we hear about computers as appliances, but I think this is actually the first example because it did a very fixed function, a very simple fixed function, not a real computer opened up to the user. So one of the first observations the researchers at PARC made was it didn't need a general purpose universal I/O bus. Not necessary. And those universal I/O buses were in the PDP-10, in the PDP-11. But you didn't need that in this system. In fact, if you wanted to expand functionality, you did it via the Ethernet. So this was kind of the breakthrough idea that led us down this path. And so again, like Bob talked about, it allowed us to have very tiny I/O hardware. In fact, most of the I/O operations were done in software, in microcode. And basically, it gave us state-of-the-art performance, just as good as those previous mini computers, but at a third of the power, weight, and cost. So the star was actually a tremendous achievement for the time that all of us are very proud of. And Bob talked about this, and I'd like to show a picture of what it was all about. Butler Lampson, basically, and some of his cohorts here at PARC came up with this idea of reworking the memory system so that the I/O devices, so that basically it was divided into 5 slots or rounds, kind of like a round robin around Robin Hood's barn. And each time a device got hold of a slot, it could move 1 memory word and it could execute 3 instructions. So this shows the 5 slots. 1 for the disk, 2 for the Ethernet, 1 for the display, and 1 for the slow I/O. And so this guaranteed that if a device needed to access memory, it always knew it could get there within 2 microseconds. And once it got there, it would always get guaranteed bandwidth, 1 megabyte per second worth of bandwidth. So this was actually a correct by construction hardware design with respect to the I/O. As long as that box ran at the clock rate it had to run at, the I/O was going to work and not have one of the terrible side effects of many of those mini computers had at the time, which was when too much I/O happened, they tended to drop data on the floor. So this was a very innovative design, correct by construction, which is a phrase I hate, but was actually true in the case of this machine. We knew it would work as long as it met the cycle time. So I'm going to do a little show and tell. This is where we get a little physical here. I've already got my fingers poked several times in the back of these boards. So this was the CPU card for Star. On the top, it's 16-bit wide, so there are 4 4-bit bit slices from AMD, the 2901s that Bob referred to. And then on the bottom was 4,000 entries of 48-bit wide micro instructions. And all of this ran at 137 nanosecond cycle time, or 7 megahertz. All that, of course, and more fits on a single chip today, so it's kind of disheartening to see more. But it's good stuff. Okay, this is a 1/4 megabyte of dynamic memory. A 1/4 megabyte. All right, a quarter. 8 times as much memory fits on 1 of these chips. If I cover up the other ones, so 8 of these fits on 1 of these today. These are 16 kilobit DRAMs, and today they're 16 megabit DRAM. So there's a factor of 1,000 in the number of bits per chip stored there per chip stored here. So that's the industry for you. Again, it's very humbling. I moved on to the memory. So what I almost forgot about the memory is that Dave Liddell mentioned it supported virtual memory. So even though the memory itself was only a 1/4 megabyte. By the way, it was nice to hear, Dave, you finally let the gate open so that the poor software people could run with more memory, because I remember it was swapping too much. But later with the 64 kilobit DRAMs, it could get up to 1.5 megabytes of memory. But it did support 8 megabytes of virtual memory, which seemed like a lot at the time. And one of the amazing things about this board is it supported error correction codes. So if there was a single bit failure, it would be corrected. And that actually was a feature that didn't show up on the PC you bought later that year. Now, the Ethernet. So of course, the first Ethernet was done here at PARC, the 3 megabit Ethernet. We worked on the follow-on version, the 10 megabit. This board, even though it looks big, is amazing. The top half of the board is the Ethernet controller itself, and demonstrates how small the hardware was in the case of the Dandelion. You have to realize that each of these little black chips maybe has 8 flip-flops in it, and 4 NAND gates, so really small-scale integration. So the Ethernet controller was only 88 chips, whereas in the mini computers that I had showed you, it was more like hundreds of chips. In fact, I'll never forget the VAX 11780 Ethernet board. It was as big as your washing machine, just for the Ethernet. And when DEC and Intel came and looked at and saw our Ethernet implementation, they just about collapsed because maybe they thought we had an advantage. But so, anyways, one of the stories here on the Ethernet was, I was designing it was called the Xerox wire at the time, and the target was 20 megabits a second. And I designed a board for a predecessor machine called the D0 or the Dolphin. And I had laid out the board, and it didn't fit. So I went to Bob Metcalf, and I said, Bob, I can't get all the chips to fit at 20 megahertz. And I opened up, everyone's got, you remember the old pictures of catalogs of parts? I opened up a parts catalog, and there was a Fairchild 10 megahertz CRC or checksum chip. So I went, tail between my leg to Bob, and I said, Bob, if we run at 10 megahertz, this all fits. So that's why the Ethernet runs at 10 megabits a second. Okay. All right, now we get into some fun stuff. Disk. This was the Shugart SA1000, which is the industry's first low-cost 8-inch disk. I'm not sure how much it weighs, but it's low cost. It was $1,000. They're actually pretty reliable. The designer of this disk might be in the audience. I don't know if Joel Harrison is here. I met him recently at Quantum, and he told me lots of secrets about the disk. And he said, they still work? He thought that apparently they thought that the heads would have welded to the surfaces by now. And some customer he said said they'd never buy them because they wouldn't last 20 years. Well, he's going to go tell that customer they're still working. So we had one fun experience with it, it's heavy, which was the disk ran synchronously with the CPU, totally synchronously, and you had to supply the clock data to the disk, and so that was tied to the Dandelion's clock. So when this system was sent to Japan, where they have 50 hertz AC motors, it didn't work, and they learned they had to replace the pulley and the belt in Japan. And so there were two stock versions of those for 50 hertz and 60 hertz. Now, of course, today, this is 8 megabytes, this is 8 gigabytes. Yeah, 1000x. So that software better be 1,000 times better. So now, and to be honest with ourselves, this obviously wasn't enough for a network system to store all those images that Dave was saying needed to be printed. So the Dandelion could also support bigger disks, Trident and larger quantum disks, which had to be in a housing all by themselves. Okay. All right, the display was 808 by 1024 columns, 38 frames a second, and you can't change that. So actually, when Dave gives the demo, there's going to be a little bit of flickering you're going to see because we can't adjust the frame rate on these guys. Remember, they're tied to the CPU clock. Everything's running synchronously. The innovative thing about the display is there are 32 extra lines on the top and bottom and sides, which are called the border pattern, and we could make that equal to the border pattern of the rest of the display. And I had an interesting explanation of this. Maybe Dave can collaborate this. Apparently, in some cultures, if you have a picture of someone with a black border, it implies they're dead. So, so they didn't want to have the display with a black border. So one of the nice features about the display is that you can make the border be any color you'd like. No dead pictures. And again, I've said the Dandelion was synchronous with the display. The CPU cycle equals 7 pixel times on the display. The memory equaled 21 pixel times, and the disk equaled 6 pixel times. So it's a pretty unique machine. Had to do something about scaling it. Okay, finally the IOP that Bob told you about. So this is where we use this Intel chip. Actually, this is an AMD chip. Kind of like an uninvited guest in some sense. I mean, it was definitely okay for running low-speed I/O. But over time, I guess it became something of a Trojan horse. It could handle this board. So as part of this board, the 8085 ran the 8-inch floppy drive, which we all recognize, which has also gotten dramatically smaller these days. The 8-inch, I guess all computers had to have a floppy. They were networked. The other things we had on here were the keyboard controller and the LED maintenance panel, which is underneath there, which tells you what state your machine is in, and connections to the laser printer, COM ports, and TTY ports. So actually, it was a pretty capable machine. We just didn't tell all the customers they could take their star hardware and hook it up to a laser printer and all that kind of stuff. But the same hardware could do that. Oh man, 800 kilobytes, as I would guess. I think the double density were 800 kilobytes. All righty, so like Bob, that's it for my hardware show until my arms can't take any more. Although I guess I could show, this was the original Ethernet transceiver. This was an evolution of the 3 megabit design. There are probably some up in the ceiling, I'm sure, still here. In fact, I'm sure there's some Dandelions probably running here at Xerox, and these machines are probably homing in on them right now. So, okay, now this machine wouldn't have been possible if it weren't for the revolutionary network design environment that had been created. I mean, I stepped out of school and walked into this environment. I thought I had walked into a science fiction novel. You know, at Stanford, I was using punched cards, and you know, all of a sudden, you know, here are the Altos with their bitmap screens and networking, and you know, I thought I was on drugs. But I wasn't, and what this environment allowed us to do was to take advantage of these tools, and we actually ran like a small startup. The one thing I don't remember are the stock options. But it allowed us to work around the clock. You know, with email, you could say what you had done, and then when the person came in when you weren't there, could read and take over from where you left off, and we actually did. We worked around the clock, and so we actually ran this project. And my father asked, how can you work around the clock when you can't communicate with people? And I just sent him an email message. What? You know, what's that? So it allowed this kind of product, and so actually from the start of the design to having hardware running just took us a year, which is kind of standard for a complete system. And then another year to announce and ship. And the hardware, like Dave mentioned, was actually announced first as a file print communication server in November of 1980, and then on April 27th, 81, as the Xerox Star 8010 professional workstation. And I found an old slide and took it down and got it scanned. This was our debug environment. It shows, this is our favorite windmill situation where we had the 6 boards in a single station where we could access all the boards simultaneously. This was Stitchwell technology, so we could turn the board around really quickly, like in a couple hours. Remember, no software simulation environment. The Alto ran this great user debug program called Burdock, which allowed us to single-step the machine and read breakpoints and whatnot. And I think that person is Dan Davies. He couldn't make it here tonight. But we were really proud of that debug environment. There's actually a person I've learned at Apple is trying to recreate this environment, so I'll let you know when he gets it running. All right, so Moore's Law has been operating since 1959. You know, the Star was, I know they sold it for much less than the list price. I just wrote the list price up there. I'm sure Dave could sell you some at a great deal. They were a little expensive. They weighed a little bit, and they took all the power out of your one core, out of your one outlet in your office. But you know, they were a third the cost, a third the weight, and a third the power of a machine which would have had the comparable performance at the time. So they were actually very revolutionary for their time. But you know, now memory chips are 1,000 times denser, and CPUs are 1,000 times faster. And so I have wondered whether software is 1,000 times better. But one thing I've noticed, looking at these statistics over the years, having worked on RISC machines since here, was the I/O has only gone up 10x. And so even though the processor and memory has gone up 1,000x, the I/O, the disk drives, and the Ethernet are lagging. So you know, if you keep making the software which faults, page faults, and uses the networks, you know, it's not going to run that much faster, really. And so actually, when you see the demo that Dave will be giving next, you'll see it's actually pretty quick, pretty capable. So finally, I wanted to say, if a picture is 1,000 words, I wanted to say 1,000 thanks to Xerox. Xerox, you know, they put the investment, they put the time in, they allowed the team to be created. You know, walking into this kind of design environment was just a magical experience for everyone involved. And you know, Xerox really deserves a lot of recognition for doing that, for allowing us to put into the marketplace a product, you know, to explore, to pioneer a product which was totally new, the new concept for a PC and a new concept for a workstation. You know, basically the world's first bit-mapped, networked PC. And 1,000 thanks go to Xerox for allowing us to do that. So that's my presentation. So next, Dave Smith's going to give us a demo, and Dave was one of the human factors designers on Star.
Thanks, Bob. This is on. Okay, so what do we have up here? Let me just, I'm about to operate this stuff. I'm going to give you about a 30-minute demo of Star from a user perspective. Here we have a couple of the first version Stars, the 8010. They were so big that they're, let's see, this is so typical. Everybody just leaves junk all over everything here. Oh yeah. There's two because there's a definite non-zero probability one of them will break in the next 30 minutes and we'll switch over to the other. Down here is the version 2 of the hardware, the so-called 6085. It's about half the volume, even less, of the first version. That came out about 5 years later. And down here, we have the version 17 of the Star system, which is a little smaller even. So here we have the Star with the skins off, so after Bob's tour of it, you can probably identify a lot of the pieces inside there. So I'm going to give you a demo. I'm going to pretend I'm a new user, and I'm going to set up a working environment, and I'm going to do a multimedia document. And I've done this a lot of times, and like the talk says, this is my last time. I've got to get out of this business. And in fact, it's hard to give a talk on Star, because more and more, when I do, people say, what's the big deal? Everybody does that. So, what? No, the screen's not supposed to be up there yet. Okay. That's a little bouncing square screensaver. Let's see. So one thing I want to reiterate from a user's perspective is thinking back to those days of the mid-70s, all the screens, all the terminals that people used in those days were text-oriented, and they all used command line interfaces. So our challenge as a designer was to try to bring the computer into the office professional world instead of trying to get the professional to become a computer user. These guys were all pretty computer phobic, and most had never used a computer before. So I'm going to talk about, I hope pretty forthrightly, Star's strengths and weaknesses. Some of its strengths still aren't in products 20 years later, and some of its weaknesses are pretty legendary. So a strength is, this was a breakthrough product which made a huge improvement in computer usability by non-computer professionals. Today it's in use, the basic interface ideas are in use by over 100 million people worldwide. It was had the first visual point and click interface. It was the first object-oriented interface. It was the first use of icons. It was the first interface to identify and follow what have since become standard human-computer interface principles. It used the first commercial Ethernet. It used the first commercial laser print server. But another way to put a spin on that is a weakness was it tried to do too much all by itself. It tried to do too many new things, and it did some well and some poorly, and really all of them had to be done well for the thing to be a success. From my point of view, I'd like to point out another weakness that I think was the biggest mistake we made, and that was to make it a closed system. As Dave Liddell pointed out, there was no independent software industry at the time, so it made more sense in context, but in retrospect, that was the biggest mistake we made. For example, the Macintosh toolbox was a huge improvement over Star. Another weakness of it was, even with all of the impressive performance that was built into this little machine, it was still drastically underpowered. And Star would run quite well on today's machines, thank you very much. But the software was about 10 years ahead of its time for this hardware. Basically, the machine was about the power of a Mac Plus, I believe. Is that? A couple things I want to point out. We used a 2-button mouse here. Okay, why 2 buttons? Because user testing showed that 1 was too few and 3 were unnecessary. The Mac has 2 buttons too, for that matter. It's only the second one is on the keyboard. And the PC has 3 or 4 or 5 or as many as you want. And that, I don't want to say anything about that. Now, the keyboard was pretty innovative. And if I was to point out the biggest reason for STAR's user interface success, it's this keyboard. In particular, in addition to the standard typing array, we had 3 banks of function keys that were hard labeled with their meanings. The most important were these on the left side. In fact, the bigger ones were the most important of those: delete, copy, move, and show properties. Those 4 generic functions were based on observations of what fundamental principles were in computers. In a programming language, those are operations you do. You copy data structures, you delete data structures, and you move data structures. So we elevated those to the level of the user interface. Across the top, we had some that dealt with text, like bold, italics, underline. And down here, we had some others. So the effect was, you could actually operate STAR for quite a while by putting your left hand on these keys and your right hand on the mouse. And if you were left-handed, we apologize. And operate STAR that way. It was two-handed operation. It was sort of modeled after what Engelbart was doing at SRI at the time. Only he was using this strange little keypad that user testing showed that mere mortals couldn't learn. But they could do this. Okay? So now one of the points I'd like to make here from a user interface perspective is that this interface has still not been surpassed in many ways today. And one of the ways it has not been surpassed is in the very few commands that you need to do complicated things in STAR. I'm going to create a multimedia document using fewer than a dozen commands. In fact, the entire demo is going to use fewer than a dozen commands. All right, what else? Oh, there's another principle. We really like this idea of Seymour Papert's about powerful ideas. Powerful idea is something of great generality that if you apply pervasively can make a system both more powerful and simpler at the same time. And as a human interface developer, that's a very important pair of criteria. So one of the powerful ideas that we adopted was the notion of copying. Copying is a paradigm for operating the system, and you'll see that in the demo. We make copying pervasive in STAR. Copying is easier for people to do than creating by scratch. That's why people, like my son here, who take tests, love the multiple choice tests, because all you have to do is figure out the most likely answer, rather than the fill-in-the-blank tests, which require you to generate something from scratch. By the way, that's exactly why the reason people don't like command line interfaces is because you're faced with a blank screen and you have to generate a command line with all the switches and everything from your own memory. Okay, so let's do a demo. Okay, the first thing we're going to do is log in to the system. STAR was networked from day one. Pardon? What is not on the screen? Oh, the wiggle. Yes, yeah, we apologize for all the shaking. If you were to come look at the STAR screen afterwards, and you're all invited to, it's really rock solid. It has to do with the mismatch of the scan rates. This is an interlaced screen, and the camera just can't get a sync rate that will stabilize it. So the screen I'm looking at is not wiggling like the one you are, and we apologize for that. So come up afterwards. Okay, so I have to log in to even do anything with STAR, but I only have to log in once. I've now identified myself to the system, and every server I go to or any other host anywhere on the network, I no longer have to log in. It will negotiate for me. Now look at the top of the screen here. See that white thing up there? That is not a menu bar. Let me repeat that. That is not a menu bar. This is an area for messages and prompts and things. Way over here on the edge is a pull-down menu, sure enough, but those are infrequently used commands that we didn't have time to get rid of. Down here in the lower right corner, good man. I have a monitor here too. This is not part of the Star hardware, by the way, this little Sony monitor here. This is our handle onto the whole world of the network. It's what we call a directory icon, and I'll open it. And it opens up into a window. And here are all the categories of things that are available to me as a new user. I remember this was my first use of Star. And so I'm going to say, well, let's see now. I want to get a working environment together that will let me do some real work. OK, basic documents. All right, that sounds promising. So I'll open that up and see what's in there. I'm doing that by double-clicking on it, or there is an open key on the keyboard that will let me single-click it and then push open. OK, now here's where I'm actually going to use this, these generic commands. I'm going to select this thing and say copy, and then I'm going to move my cursor over here to the right and deposit it. So that was the use of the copy key. That got me one of these things out onto my desktop. Now we're going to go back over here and copy some others in. Pardon?
You didn't call it a desktop.
We did call it that, yes. And in fact, it was very deliberately called a desktop, and the icons chosen were very deliberately chosen to be familiar to the Office professionals. So the way we chose them is we looked around the office and, well, let's see, there's some folders and some documents and file cabinets and, well, maybe not printers, but there's a bookshelf and a wastebasket and so forth and so on. And so those are the icons that we built into Star, trying to get the computer into the user's world. Okay, so I'll copy out a folder. What else am I going to copy out? Here's something in our records file. This was our equivalent of a database. And so I might want to use that. Here's a spreadsheet, so I'll copy that out. What the heck? All right. That's all of these things. So let's go back and look at our categories again. Okay, filing. Well, let's see what's in there. A bunch of file servers, and you can see we've named them like universities. Okay, I don't want to do that. I'm just going to go on. Okay, mailing. That sounds promising. I'm going to want to do some mail. All right, so let's see what we got here. Okay, an outbasket. That sounds promising. So I'll copy. Hello, there we go. I'll copy the outbasket and in basket. I'm selecting these things, and in every case, just saying copy. Right. So far I've used...
Dragging.
Pardon?
You're not dragging. It's not a click and drag.
No. It's a noun, verb, destination.
You got mail, Dave.
You have mail.
Oh, I got mail. Gee. From 1980... I hope the issue hasn't expired here. I better read that. I'll read it a little bit later here. Okay, well, let's see. We're going to want to do some printing, so I'll get a couple more things out. I think by now you're getting the idea. This is a browsing interface to the network. Basically, this use of the directory icon allowed us to bring Star's interface ideas to the world of the network. It wasn't until Anderson did, what was it, Mosaic? What was the predecessor of Netscape? Mosaic, yeah. Until he did that, we had a similar interface to the network. Okay. Okay, this is probably enough of that stuff for now. So I'm just going to close my little directory. So now let's take a look at this whole screen here. So this is what I've set up. I've set up some documents, some folders, a database, spreadsheet, mail, printing, ready to do some work. So let's go to the blank document. And now here's where copying becomes pervasive. The way you work is you make a copy of an existing document. And then you edit the copy. So therefore, every document becomes like a form pad, a source for new documents. There's no special concepts needed. So I'll open this. Oh, let's see. Before I do that, now I'm going to show you another key I haven't used yet, the Show Properties key. I said that STAR was an object-oriented interface. These little pictures are not just pictures. They are objects that have semantics. They have both state and behavior, like any object in object-oriented programming. And when you say show properties, it will show you the state. So this one has things like a name and a couple of information-only properties. So I'll call this the history demo. All right. So now my little blank document becomes a history demo. So now I'll double-click on it and open it up. And sure enough, it's blank, just like the source that you... Now let's go up and look at the top of the window again. Okay, there's 3 commands here. This question mark is for context-sensitive help. This closes the window. And this causes a paginate or layout, page layout to happen. Way over here on the right is a pull-down menu of commands that deal with tables. And even further is another little pull-down menu of infrequently used commands that we didn't really want you to pay any attention to. Let's go up and look at this top thing. This is still not a menu bar. This is it. These are the commands necessary to construct a STAR document. Okay, so let's start doing some stuff here. Okay, this is very tiny, so let's, the first thing we should do is make it larger. Now, I'm going to select it and hit the Show Properties key, because like anything, text characters are objects. So they have attributes. They have both paragraph and font attributes. So these are the paragraph ones. I can make it centered, saying double width, double height. Let's go look at the character properties. Okay, let's make it the classic font, which is serif, 24 point size, and bold. Okay, so when I say done now, that thing I selected turns into those properties. Very nice audience here. You're all invited to the next last talk. Actually, there's the penultimate last talk, and in April we gave the ultimate last talk. So this must be the post-ultimate last talk. Okay, so now we'll type some more stuff. Okay, well, let me see. Now, this is a little too big, so I'm going to select this whole paragraph. Now, I could bring up the property sheet, but that's what the top row of function keys let me do, is they're accelerators for having to go to the property sheet and click those properties. Oh, okay. Here, this top row of function keys. Never mind. So I can do things like I can make it centered or not centered, and I can make it larger or smaller just by pushing some of those keys. And so common operations could be done using those top row function keys. And I'll show you, in fact, that those are virtual keys that are remapped as the context changes. Okay, so now I'm going to show you a new thing here, a new function called the keyboard, the virtual keyboard. So I'm going to push the keyboard key. And when I do, you'll see that at the top of the window here, that top row of function keys, of which there are 8, get remapped to these meanings. So I'm going to show you the key by pushing the show key. And down at the bottom of the screen, the virtual keyboard shows up. And so I can say, okay, let's just see some office symbols, or math, or logic symbols, Greek letters. What else? Italian, Spanish, Russian. Or maybe the Dvorak keyboard layout if you'd like to set it to that and type with that one. But what I want to do now is I want to go to the special keyboard set, and these are smart characters or smart objects. And one of the ones I'd like to do now is insert a graphics frame. So I'm going to hit the A key, which says a graphics frame. And back up here in our document, a little frame will appear.
Yes, you could click on it. I just move the mouse to it.
The question is, could you click on those virtual keys with a mouse? And the answer is yes. Let's see, before I do this, I'm going to move this keyboard window off to the right side of the screen.
So it has properties as well.
Yeah, so it also has some properties. And then I'm going to center this thing again. OK. Now, when I select the frame, this graphics frame, you'll see that the top row of keys automatically got remapped to graphics type things like stretch and magnify. So I'm going to push the stretch key, and now I can adjust the size of this thing. OK, great. What I want here is a bar chart. So I'm going to go to the second document that I copied out earlier, this basic graphics transfer sheet. This is modeled after the rub-off sheets that existed in the day. These were little sheets, transparent sheets with graphical symbols on them, and you would put them on top of a typewritten page and scrub on the back of it with an eraser, and it would transfer the symbol onto the page. Well, we did the same thing, only electronically. We have little electronic transfers here. So we have some simple ones like lines and rectangles and ovals. So I'm going to select this one and say copy. And using that same command that I've been using all along, the copy command, I can get a copy of it, and I can stretch it since it's a graphical thing. And so I'll stretch it out a little bit here. All right. Let's see. Let me move this thing so that I get it where I want it. I got kind of a sticky mouse, so it's hard for me to do this. All right, that's basically good enough. So that's a very simple little graphic transfer. Here's one that maybe is more interesting down here, is a bar chart. This is a complex object, but I deal with it in exactly the same way. I select it, I say copy, and I click where I want the copy to go. And I can stretch it using the stretch command. So even though it's got a whole lot of semantics to it, the interface is the same. Let's see if I can actually get the, hello. Oh. Why can't I get that? There we go. Boy, my mouse is definitely sticky. OK, so I'm going to stretch it out sort of to fill this little oval. Now, it's an object like any other object, so it has attributes, and so I can use the show properties key to see what they are. And here you'll see it has some pretty fancy stuff. It's got some spatial properties, and it even has a table of data. So what I'm going to do is I'm going to fill in the data table. I'll type some demographic data for Kerbo and me. Let's see, what we want to do is fill in by column. So now when I hit the next. Okay, so the first thing maybe we'll enter for you guys is our heights. Hello. Dave's about, I don't know, 75 inches tall. And I'm about, oh, shall we say, 50 inches tall. And we'll get even more fanciful here because we'll do weight. And Dave is about 215? Yeah. Going for the gold, huh, Dave? And I'm about 150. There's my little data table, and I'd like to plot this data into the bar chart. That's what bar charts do, right? So let's go back to the spatial properties here and get this chart looking the way we want. So when I switched these little tabs or pages, it plotted what it knew so far, and there it is. I don't like that. I want just this kind of thing. I want the bars to be side by side and a little spacing here. And oh, by the way, that one color is kind of beading on the screen, so I'd like to change the weight color, say to be black. And now when I say done, it will apply those changes to the chart, and there you are. Let me just center this guy again. Well, I wish my mouse wasn't quite so sticky. Okay. Okay, well, we're done with this little transfer sheet. That was pretty painless, you know, as a person who had to create a chart, maybe against a deadline or something. Let's, I'm going to just insert one other kind of thing here. We're going to, using our special keyboard, we're going to insert a equation frame, which we do with the C key. And now when we inserted this equation frame, it automatically positions the caret, the type-in point, inside the frame. And I can type some standard ASCII, like f of x equals. I apologize for not being able to make this larger. This is the largest font I can do with this version of star. And now I'd like to say maybe do a quotient here. So if I go to the equation frame now, if I go to the special keyboard now, the fact that the context is an equation frame gives me a different set of special characters, equation type characters. So it's context sensitive, so I can say I want a fraction, and in the numerator I want a summation. And you'll see that it positions the caret automatically in the lower limit of the summation. And I can type I equals 1, and then hit the next key. Now the next key, actually I was using the next key. I forgot to tell you about it when I was stepping through the rows and columns of the table. I was doing that with the next key. And now I'm going to use the next key to step through the parts of an equation. So when I hit the next key, it jumps to the upper limit. And I can type 100. And hit next. It'll jump to the right side. Now I don't know if you can see it or not. Maybe you can see it in just a second. But I'm going to say x sub I squared. There's a couple of things I'd like to point out. First of all, can you see that the letters are in italic and the numbers are in Roman font, which is proper equation formatting, and I did not have to switch the font to get that. Also, the superscript is directly above the subscript, not offset to the right as in word processors, which again is correct equation formatting. And it does that for you automatically. So I'll just type some more stuff, some random, see a product, say over J, and we'll say it's a Y sub J. And now if I keep nexting, I'll eventually get to where I want to be, which is in the lower limit. For this, maybe I'll insert a integral from A to B. And let's use some Greek stuff here. So I'll choose the Greek special character. Say rho of theta and then d rho, I guess, would be the way to d theta. So I just created a mathematically typeset correct equation. This is very rewarding, Dave.
Are you sure this is the last one?
The last clause of that statement was going to be only using the special keyboard. I didn't even use the copy those commands this time. All I used was the special keyboard feature and this smart equation objects. All right, in the interest of time, I was going to introduce, insert some things like fields and some other objects, which I could do into this multimedia document. One thing I do want to do is get rid of the frame border around this equation, this graphics frame. So the graphics frame itself has attributes just like the objects inside it. Its attributes have to do with its border and whether I want it centered or so forth on the page. And now I'm going to, now here's where a weakness comes in of star. I actually, to get this to look the way it will look when it's printed, I actually have to explicitly paginate it. The hardware simply wasn't able to keep up with interactive pagination. Sorry. But let's step back and think about what I've said here. Okay. So I've created a multimedia document, properly typeset and laid out in a WYSIWYG fashion. If I were to print that, this is exactly the way it'll show up. And I did it with fewer than a dozen commands, as I claimed I would do. If I wanted to print this thing, I mean to say, well, print it, or to mail it, what I would do is drag it to one of these icons. So in fact, here is where, I guess I forgot to point out when I was talking about icons, we divided the icons into two classes, data icons and function icons. The function icons operated on the data icons. The data icons were documents, folders, record files, spreadsheets. The function icons were mailboxes, printers, file cabinets, and so forth. The way you got a function to operate was by using the move key. You selected a data icon, said move, and then clicked on a function icon. So I've just invoked the mail command by using the more generic and general move command. So all I have to do here is type a address, say done, and it will go off and mail this thing for me. So I want to sum up here. There's a couple of lessons that I think bear thinking about. 17 years after STAR came out, 1,000 times later in machine speed, memory density, and disk density, STAR's interface still is simpler and more consistent and more usable than the systems we see today. In fact, the most pleasant experience for me in this whole thing, actually Dave Kerbo's had to do all the hard work of making this hardware one. All I've had to do is get familiar with STAR again. And the most pleasant part of all that is finding out all over again how well STAR has survived, how well the ideas have held up in the intervening 17 years. It doesn't seem like an antiquated system. In fact, if there were any way I could use this thing, I would. But there's nowhere I can print it. Nothing I can print it on. Nobody who can read this email. This email, by the way, that I just sent, you know, it had equations in it, and it had all sorts of non-ASCII stuff in it. But it doesn't matter. It just all went.
Maybe somebody will write an emulator.
Yeah. The way, so STAR had many fewer commands than today's systems, and it didn't do it by having fewer functions. It just had fewer commands. And the way we accomplished that, I hope I illustrated, was through the use of generic function keys, through objects that had property sheets, through virtual keyboards, and through smart objects that would do a lot of the hard work for you. We also had a taxonomy of icons, data and function icons, that led to simple ways of doing things, namely you move to a function icon, and that handled a whole bunch of commands there. And lastly, this notion of a copy paradigm meant that I could do quite fancy graphics if somebody had created a little graphics transfer sheet for me to use. All I had to do is then copy those things into my document. Okay, that was pretty much the demo. Now Dave Kerbo is going to talk about some of the technologies other than this interface. Obviously, the interface has been picked up by all personal computer manufacturers and most workstation manufacturers. But there are a lot of other technologies in STAR that have also been picked up by other companies, and Dave's going to cover some of those.
So the version of STAR you saw is the version that they were working on when I arrived in '83. And if Robert was blown away when he came here at the hardware design, I was really blown away because I came from a mainframe operating system background just before this. And I'm very proud to have been able to work on this project for so many years. My job in this whole thing has kind of been, I had some hardware in my garage that I got from Alan Fryer and some more people. And in the course of my work, I managed to figure out how to make it work again. And so we were able to do a demo for the CHI conference, Human Interface. In fact, I became a human interface designer at the end of my Xerox stay because I was so impressed with the user interface and I wanted to do a better job for everybody else. So I went to Apple and worked there as a human interface designer. Well, long story. So we went to the CHI conference and everybody was really impressed, and John Schock suggested that we do this again. And so since everybody's covered all the interesting things, I thought I'd tell you about the, well, not the interesting, but some of the things that people don't really notice. Could I have the slides, please? Thank you. Great, I hope. So all of those wonderful things Dave showed with equations and all that, that worked because we had, not just ASCII. And also, we supported, oh gee, let's see. In the very first release, we had Russian, French, Swedish, lots of other things. And then like 6 months later, we supported Japanese. So in the end of '82, I believe, is when JSTAR came out. And it may be tough to see, but this is actually Japanese typed on the screen and printed. And in the course of the next few years, Xerox character code standard, which became Unicode, really. Unicode came from this, supported every major language. Some little known facts. Some of the other innovations you may not be aware of. Directory services, we call them clearinghouses. They derive from originally Grapevine here at PARC on the Altos. Now, 18 years later, they're all the rage with LDAP and Microsoft Active Directory. Of course, Novell did support directories for a number of years, and they were, I'm told, extremely similar to Clearinghouse. Courier, remote procedure calls, originated here. Of course, it originated with the Altos first, and we productized them and shipped them. Print protocols, the internet printing protocols that you guys, if you're really into printing, you may care about, derived from here. CUSP. CUSP was customer programming. Basically, it was in-user programming. It was intended to allow users to program. Well, it actually turned out that more like consultants program, but anyway. It was an English language programming tool that was extremely popular with some of our major customers. I'm told that Lufthansa Airlines did everything from menu planning and everything else using CUSP. That's kind of metamorphosed into Metaphor capsules. slightly different, and AppleScript, a project I worked on at Apple for a while. The intent was, again, to allow users, well, really consultants, to be able to automate stuff on the system. Boot servers. Well, boot servers, if you use an Alto, you knew you downloaded things like Maze War and other games and applications. In our product days, we shipped something called boot servers, so you could boot installer and utilities and things like that from the network. That's metamorphosed into application servers that now download things like Java applets. WebLogic and Kiva/Netscape do this now, very popular. Only so many years later. Remote access. The ability to, from someplace remote, like your home or someplace out in the field, dial in through a modem and be connected transparently to the network at the other end, caused Alan Fryer no end of grief trying to make it all work, but you were on a very slow Ethernet connection. And of course, that's extremely popular now in the nomadic world that we live, where everybody carries a notebook computer and they want to plug in, but they have to dial in to work to get stuff. So that's just a few of the things that we did. I want to say thank you for all the people who helped make this happen, like Kathy Ching and Stella Timmons and of Xsoft, who provided me with some floppies that they managed to find, as well as some hardware. Alan Fryer, who helped make all this hardware work in the first place, and of course Tony Stafford, who has a garage, I'm told, full of Metaphor machines. These, in fact, are 10 megabyte, very first 8010s. So they're very old. We're very happy that they're still working. He also managed to find in his garage a box of software that when he left Metaphor, or Metaphor got rid of the stars, whatever it was, this stuff went to his house for some reason, and he had a box of software. Oh, I'm sorry. Excuse me, Dave. So anyway, there's, in this box we found software from 1983, 1984, which we actually last night loaded floppies from 1984, 8-inch floppies that still loaded and still worked. We did have a bit of a problem with product factoring, trying to find keys to unlock it, but a scrap of paper was found with a password that worked, and so we were able to last night product factor things and make it all work. So we're very, very thankful to Tony for stashing this stuff. And of course, to the hundreds of people here who worked on Star, of which I was just one of those people. Thank you for coming. And now we'll do Q&A. Oh, I'm sorry. There is two more things I should tell you. Let's see. If you didn't sign the poster outside, the people who worked on the Star, please do so. There's a poster somewhere. And the Xerox Star retrospective, which Jeff Johnson and people worked on, Jeff has kindly provided a few copies if you're interested in that. And now we'll do Q&A. So.
Very good.
I'd like to say something about the Q&A session. I've heard it said about history programs that question and answers go on too long. And I'd like to point out, first of all, it's valuable information for historical record. We tape these programs for that, so I'm not inclined to stop the question and answer at any point. And anyone who wants to leave at any time is perfectly free to. You don't have to now or during the question and answers.
Peter.
Those who do not learn from history are compelled to repeat it. And I'd like to suggest that even though many of the good ideas in STAR have been published and published well, that there are also important aspects of it that don't really transmit their value to subsequent generations except in the form of code. So I'd like to ask the following two questions. Number one, can anyone make a substantial case why Xerox should not put the entire source code of STAR into the public domain? And number two, were Xerox to do such a thing, would it be possible to find it?
We should repeat the question for
Mark Weiser at this point.
Peter's question is there any substantial argument as to why the star source code ought not now to be put in the public domain. And secondly, if there were an agreement that that were an acceptable thing to do, could anyone lay hands on the original star source code or a facsimile thereof in order to do that? I can't possibly answer either of those questions except to say I cannot myself automatically see a reason why it couldn't be as some other classical source code is in the public domain. But that would be an issue for Xerox to sort out. The other question, though, about the availability of it, who knows? I imagine it must be around.
Has an answer for that.
Well, in fact, up until 2-3 months ago, Xerox was still supporting the products. There had been a new virtual machine implementation built that ran on top of Windows. It runs very fast, actually. And they tell me that they have gigabytes of stuff, but they're not quite sure what versions and stuff because it's just a small crew that was finishing the maintenance. They stopped supporting it just recently. I suggest you talk to someone at Xerox.
Who?
Mark Weiser is nearby.
I'll look into it. Thank you.
You said there was the virtual machine?
There is a virtual machine implementation. It is a Xerox product that was sold until about 2 months ago.
It runs on?
It runs on PCs, Windows.
We have a question way over here.
Is the STAR program, the year 2000 compliant?
Is it year 2000 compliant?
No way.
Oh, there's a wonderful answer to this, actually. Although it's not year 2000 compliant, it does have some fairly nice features about dealing with dates and other things like that. When is it? It hasn't blown up yet, though. Is it year 2000 when it hits the wall, or is there something earlier?
I think the timestamp actually blows up around 2020 or something like that.
Yeah. I think that there is a problem with the configuration software, which if Alan can rewrite it, it doesn't let you configure a new star. I tried entering 00 and it said no way. But that's just, actually. That's your code? Okay.
Yeah.
But that was,
Well, but
that's just the code to set the time on the machine. It had a few idiosyncrasies where it really couldn't keep time forever. We tried.
So it is year 2000 compliant. It's not year 2020 compliant.
Ron Crane.
Side note, the XNS time protocol is a 32-bit number, which is the number of seconds since January 1, 1901. And that 32-bit counter rolls over around 2020.
Yes.
I have a question regarding chip widge. Who's the person who designed it? Xerox is still using it. It's a wonderful program that IC designers will love to have them in their hands. Do you know anything about it?
What was the name of the program?
Chip widge.
Chip widths? Well, a little programming for...
We use it in El Segundo for IC design.
We're the wrong guy to ask that question.
Oh, no.
Sorry. We just use SIL, and you weren't allowed to design ICs. Yeah, wait a minute. Oh, Charles. Yeah.
I'm Charles Irby. One of the things I thought would be useful for Dave to comment on is the design methodology that we use, and the fact that we designed this based on abstract notions of what the functionality were rather than the specifics of the user interface. So Dave, maybe you could say some more about that.
Yeah, that's an interesting point. I'm the first, Dave. You're the second.
Why don't you repeat the question?
Charles asked about some comments about the work that was done on the design methodology. Dave Smith referred earlier to the fact that it was done in a principled way. In fact, I commissioned you might say, a task force, which Charles Irby chaired, as it were, to develop a methodology first. So before we did the design, we decided on a methodology for user interface design, so that we'd be able properly to manage both the process and the abstractions that we were going to be working on. And then as the user interface design was done, in stages and to attack different tasks, there was a very sort of consistent approach. The information display was designed independently from the function invocation, for example, which turned out to matter a great deal. And both of those were designed independently from the user's conceptual model. And this was the first time that anything like this had been done, either the development of a methodology per se or then a principled user interface design. That's one of the reasons why STAR, from a usability point of view, is such a great improvement over most of its successors, is because we actually did it by designing it using a set of principles rather than just sort of randomly copying what someone else had done or kind of debugging it into existence. So that turned out to be very important. Charles himself and Dave Smith, Eric Harslam, and Ralph Kimball, along with Linda Bergstenson, and a number of people from PARC who were still in PARC proper but were happily helped us by joining our task force. And I include Larry Tesler, Charles Simony, at least Bill Verplank, a number of other people as well. So it was a big and very focused effort. Some people thought, gee, it's a long period of time just to decide what you're going to decide or to design how you're going to do the design. But I feel that it really served the process and the subsequent industry very well. Yes?
It seems pretty clear that one of the major shortcomings of STAR was the thing that you cited about the turnkey closed model, as opposed to somehow seeing in the crystal ball that the independent software market was going to come into existence. There was some speculation at PARC at the time that such a software market would come into existence, but of course it was all just speculation. I'd be curious about what you think and what Dave Smith thinks also about whether that was something that at the time was just impossible to have foreseen in the STAR program and would have just been overreaching itself, or whether looking back on it you feel like, gee, you know, I wish we'd gone the other way and tried to make it an open platform.
Well, I'll say what I thought, and I think other folks should too. The question was, in retrospect, doesn't it seem as if you could have thought that you should provide more of a programmable open system, even though there wasn't an independent software industry at the time? And we actually did make the XDE, the Xerox Development Environment, in such a way that it could be packaged up and shipped. And we did begin shipping it to customers about, if I remember, about 18 months after we launched the product. It was, however, designed for fairly serious hardcore programming use, and we did not understand a lot about what it meant to export and support that kind of an environment. But it actually always was a part of the plan to do that. We just did not put it in front of the other objectives. Later on, of course, some of the objectives for the program changed, but I generally feel that if it had happened earlier, we might have been more a part of jump-starting a better, earlier independent software industry. The first few years of the PC software industry were pretty rocky, and largely because of the tools and so on that were available. So I see it as an opportunity partially missed.
Actually, there was a, when I first got here in '83, there was a project called Phoenix, which was taking essentially the Tahoe toolkit. Dave mentioned that, I think he mentioned today, maybe he mentioned last time, that one of the problems was we didn't have a toolkit installed that drawing on the screen required everybody to draw on the screen. Well, in Tahoe, there was a toolkit for doing that. And in the Phoenix project, a toolkit was built. And originally, and it became Viewpoint. Viewpoint was an open toolkit-based architecture that intended for third parties to develop software for. You had to develop in Mesa and required a little more learning than what most people had. But about 84, 85, we started shipping Viewpoint to allow people to do just what you suggested.
Turn up the volume, someone requested.
Oh, can we have the volume up a little higher?
I would like to make one more comment about the previous question, Charles Irby's question about the design methodology. Dave Liddell is correct that before we did the design for the design. And it's interesting that the principles that we came up with are no big surprises to people today. Anyone in the human factors business, anyone who goes to a SIGCHI conference or reads the journals, it's all pretty standard stuff. It was doing user testing. It's analyzing the tasks that users are doing in their context, trying to figure out what objects they're using and what actions they're performing on the objects. And in fact, we went out many times in the early days to various sites and decomposed in excruciating detail the tasks that people were performing, went back and did a design that would enable you to accomplish those very same functions, but hopefully in a much simpler and more improved way. I think it's very revealing from an historical standpoint that the SIGCHI organization formed after STAR came out. The first SIGCHI conference was in 1982.
Yes.
I have some information that might be interesting to the speakers. I work at PARC, and just last week I had a visit from a colleague in Fuji Xerox, the Japan branch of Xerox. He told me that I guess to a global view of JSTAR, that product in Japan is still active, and had been, and that Sony Corporation this year had selected it for a system D that they have. And then, for good measure, we opened up global view system here and the network icons. And I dropped a document on this guy's printer at Fuji Xerox in Japan, and it worked. So,
Speaking of JSTAR and Fuji Xerox and so on, I very well remember when Bill English and I and Joe Becker and others were there for the launch of the Fuji Xerox JSTAR. Bill and Joe, of course, had been there in Japan several years getting that program working. And I was not very used to the way that literal translations from Japanese turn into English phraseology. And so after the launch, that is on the day of the launch, the booth was absolutely packed with people of all kinds, particularly competitors, people from other companies and so on, looking at the product. And I remember one of the Fuji Xerox marketing folks translating for me the review that was written the next day in the paper. And he said, it was clear in real time, he was thinking how to phrase this back to me, and he said, the Fuji Xerox STAR is as different from conventional computer interaction as clouds from mud. And I thought, boy, you can't do any better than that, you know.
Wait, hang on just a second here. I think that as long as we're talking about the international features of STAR and how they were a big element in the sales that we did have, we should recognize the years of hard and very creative and dedicated work of the man who was largely responsible for the internationalization of STAR, and that is Joe Becker. Without whom a lot of these tough issues, especially like making a selection in Arabic, which starts like this, and then if there's an English word, it'll go the other way, and then when you go back to Arabic, the selection will go the other. And he made it all work.
That. Oh, and then he said, and what if the writer is writing in Arabic and they're quoting something in Hebrew? Right. That's what's really
he figured it out.
Right. Yes?
My name's Mike, and I've been very curious about what kind of tools are used to create these programs with, other than the what you call traditional teletype tools, the old word processing, assembly, and compilers, and whatever. Is there any new environments that are coming up which are more real-time interactive for low-level machine language, native machine language code. The only things I've seen require you to stop the programs before you make changes. I wonder, is there any, where I could get any information about full bandwidth, object-level programming and debugging environments, which I'm not able to find. It's usually hardware-based in circuit emulator. I wonder how you actually work with this new programming, how anybody who writes programs today with the old stone knives and bear skins and whatever tools that they're using. So I look at SD98, that systems conference, and all kinds of news groups, and couldn't find a thing.
Palo was extremely fast at the time. It had things such as, I remember the debugger, you could, at some point, if you realized you'd screwed up, you could back up and say, no, do it like this. Back up down the call stack, force a call differently, passing different variables, and go in and say, no, skip over this and do that. And this was in 87, something like that. It was just amazing tools available that, according to my friends who are still writing code, tell me they're just now starting to see this stuff in some of the new Microsoft products. I'm probably the most nerdy person in this group, and I can't answer the questions anymore since I've done human interface. But if you find, like, oh, this man right here, Charles Haynes, who was the debugger person who put in, well, and other things. Talk to him afterwards, okay?
Significant. And did the machine actually end up on the desks of high-level Fortune 500 executives?
The question is, for how long were sales significant, and did the machines wind up on the desks of Fortune 500 professionals? I can answer the second part. I was only here through most of 1982, and then went off and tried to put it similar but different machines on the desks of Fortune 500 professionals, not to print documents, but do other funny data-like things. It is certainly the case that the primary customers were the biggest customers you can imagine. That is, it did indeed go virtually always to professionals. As a matter of fact, it was hard to get the sales force to quit trying to sell it to word processing people. Word processing people were proud of their ability to withstand pain, and to know all these complicated commands, and they were not the target. And it definitely went, in modest numbers, I admit, to that very target audience. Who can say what was the period over which Star was sold on the various different platforms, including the Sun? I don't know if any of us have the right answer for that. Yes, way at the back.
I fell in love with your design, and I wanted to say thank you. But I also wondered, who invented the undo command?
The question is the question following a complimentary statement about our design. Who invented the undo command? Now, as far as I know, Warren Titleman invented the undo command in Interlisp, or its BBN Lisp, its prior name. I believe that's true, and it was culturally very strong here in PARC, and so it was not optional not to have it in the system. I think it's fair to say that the ability to make text editing documents undoable flows from J. Strother Moore's piece table invention, which was the thing that made it possible to have a text document in which you could still undo it by not irrevocably committing the data structure. That at least would be my assessment. What else? Yeah.
As far as undo goes, we might as well come clean here. Dave's trying to get a picture of the keyboard. If we could switch to the camera for a second.
Oh, right.
Well, there is a key labeled on the keyboard, undo.
Oh, he's got it now, Dave.
Oh, he's not.
He's got the camera now.
No. At any rate, it's one of the function keys on there. And we thought that as designers, that was enough to ensure that it would actually be implemented. Unfortunately, in our naivety, we were wrong, and it was never implemented, and Star did not actually have undo. However, We did have one thing that we did win when it comes to undo. We used to have a contest. Can you find the sentence in the star functional spec that causes the most implementation work? That was the sentence. Every command can be undone by pushing the undo key.
Right. Yeah.
When you talked about names for the product, that one of the original ones was to be Daybreak for the star. And how did the term star, how did the name star come on?
The name star was made up by Bob Spinrad, who was at that time vice president of system development. He was the head of SDD at that time. And he and I were once again trying to sell it to yet another skeptical senior executive. And we had just been put into the clutches of Dave Culbertson, who happened to be a sailing enthusiast. And so Spinrad said, let's name it after a sailboat class, okay, a one design sailing class. Maybe that will cause him to be interested in it. And star, well, you know, it wasn't very easy to get Dave interested in things. You know? And the star was both a decent, interesting one design sailboat and also a tolerable name for an office appliance. I mean, we looked at a number of other ones, but, you know, somehow lightning didn't quite do it, and, you know, sunfish and everything else, but star seemed okay. That's where it came from, yeah.
Yeah, Daybreak was the name of the 6085 launch.
Yeah.
Machine now at the end.
I'm sorry? What was your question?
Is there any idea how many were actually ever produced?
Something like 30,000. Yes.
About the object-oriented GUI, which I'm a strong supporter of, but recently you may have noticed there's something of a backlash against object-oriented GUIs, or maybe it's more of a muddling would be a better word for it. With the longest perspective, perhaps, of most folks on object-oriented GUIs, has your faith in object-oriented GUIs been shaken at all?
Not badly enough to call them GUIs, but we know it.
Keith Henson, out of curiosity, if you were to look at the descent lines from the star, there's a lot of, what would be the first and maybe some of the second layer ones that you would consider to be obviously descended from the star, at least in idea, mimetic concepts, if you will? I'm thinking particularly that the Leeson might have been the closest.
Well, there are a few that were licensees, okay? That is, there was a product done at Sun called, I forget, but it was
the port to the sun, the port to the sun.
There was a toolkit done at Sun under license from Xerox. Oh,
OpenLook.
OpenLook, thank you, right, which was a direct descendant. Similarly, the product that we did at Metaphor, we actually had a license for as well, and it was a clear direct descendant. Lisa had some similarities and some differences. It was more similar than the Macintosh was. Obviously, there was, you should pardon the expression, next step, and motif. What was the, yeah, the PARC had some similarities and some differences as well. What else? Other guys can think about it.
Well, actually, this article by Jeff Johnson that Dave referred to, which are up here, has a very nice chart in it that has quite a dependency graph of star and everything. So you're invited to come up here and take a look at that.
A lot of hay has been made over a certain visit by Steve Jobs when he showed up here and looked at everything. Whether that exists or not, maybe there's a story there or maybe not. But I'm more curious. You would read a lot, especially maybe in the last 10 years, about how Xerox invented it and everybody else got rich off of it. And I'm just curious from what was the, what can you say about the attitudes or the feelings inside Xerox, inside PARC, watching these other machines, garbage, not so much garbage, whatever, making a lot of money. Was it the proud child of our ideas? Was it the goddamn thief of
How
our
is this
ideas?
guy anyway?
We just thought it was great. We just simply wanted our ideas to go out there in the world, and we weren't at all concerned with commercial success. Ken.
My name's Ken Peer. I started off before the star in that division. Dave hired me in. I've been at PARC for about 20 years. I just want to say this in public. 2 of the inventions at PARC, okay, make Xerox over $2 billion a year in gross revenues. Just 2 of them, all right? So we're very proud of the money that we have made for this corporation. And they are the Docutech and the Docuprint printers. The other... Dave, I thought you were going to tell one of my favorite stories, and I just have to substitute a couple of words. Remind me, the star, I think, was unveiled at the 1981 NCC for the rest of the world, and the booth was packed, and the Japanese press was there, and they went back and wrote all about it. And when it was translated to me in just the same way, the translator looked at it and said, "This says that the Xerox star disemboweled the competition."
Yeah, I decided to leave that part out, but that's true.
Research.
Bob.
Yeah, Dave, I heard a rumor a long time ago that when the Department of Defense was designing Ada, they came to Xerox and asked if they could use Mesa instead, and we said no. Is that true?
Bob's question was that he had heard that long ago when the DoD had that high-order language thing on the street, what eventually became Ada, and that they came to Xerox and asked if they could, quote, have Mesa, and that Xerox said no. I don't think that's quite correct. I do remember someone asking permission for us to give a briefing to the Ada committee about a number of the features that were in Mesa, because we hadn't at that time yet really written widely about at least some of the features that were in Mesa. And we did sign off on that briefing happening. I think what you may have heard is that we were asked if we would like to take essentially an ARPA contract to, as it were, harden Mesa to be that Ada, and we said no because we didn't want to do contracting. We were actually trying to construct these commercial products. But that's my recollection about it. Peter, do you remember anything about that?
What was just said does ring a faint bell that there was interest in Mesa as part of the Ada effort. I don't remember whether, and I'm pretty sure that there was some Xerox political reason why Mesa was not submitted as one of the candidates in the Ada competition. The person who probably would know the most about that is Butler Lamson.
Yeah, maybe Satterthwaite. I remember coming to me and asking how much can we
Sweet, do you know anything about that?
No more than what you said.
Okay.
What about,
Go ahead, Shan.
what about Niklas Wirth? When he was at PARC, he patterned a lot of Modula 2 after Mesa. Is that correct?
The question is, did Niklas Wirth's visit to PARC and his exposure to Mesa have impact to how he designed Modula 2? I think he certainly has said that. I think he's quoted that as one of the sources of his ideas. Yeah.
The Xerox, the interface from Star clearly made text-based interfaces obsolete, command lines obsolete, and it hasn't really been bettered in 17 years. But someday, it's obviously going to be obsolete too. And I was wondering if you had any ideas or thoughts or any research that been done in Xerox about stuff that's way beyond that type of interface, as far as the user interaction.
The question was that given that the Xerox Star and the interface approach that it sort of exemplifies or embodies still seems to be a leading form and the strong successor to the old text-based interfaces, He was really asking about opinions about things which will compare to the Xerox star as clouds to mud. That is, what is it that will obsolete the graphic user interface?
I think the answer is pretty clear. It's Windows 98.
No doubt about it. No doubt about it.
Well, except that, of course, even today, Xerox PARC is really working this area, as did Apple Labs when we were there.
I will say one thing in seriousness, though.
As I was one of the designers of the star interface, I am a little disappointed that in the last decade we haven't really pushed much beyond this desktop metaphor with its documents and folders. I mean, even at Apple, I was unable to get them to willingly go beyond this metaphor. They were just too successful for too long and developed too much inertia. I would like to see it pushed in directions of information retrieval. One of the neatest things about the internet are all the search engines that are out there. Those are just great. And there's no reason you can't do that on your local machine as well. And there's a lot of areas that we could make progress in. And there hasn't been sufficient, anyway, innovation in the last decade. I'd say that's pretty clear.
Yeah, I'll second this as a hardware designer. Having our MIP rate go from half to 500 and seeing the user interface barely change has been an incredible disappointment. I remember on the Star software, if you wanted to run the spelling checker, that was a big deal. You waited a while. In fact, we had spelling checker servers. Now so this is the biggest change that's happened in 10 years is now PowerPoint does spelling checking while you're, entering the characters. And I predicted that would happen someday, I remember. So that's the only change I've seen now in 17 years is spelling correction is as you type.
Also, paginate.
Don't do that. Don't do that. Yeah. Okay.
Actually, Word still has pagination. It's called fast save.
I spent some time at SPI. I spent some time at Silicon Graphics working with the Nintendo game machine and technology and so forth. And even though I'm not a video game person, if you look at the number of children that are growing up with amazing skill at playing these very, very fast video games, and you think about some of the navigational technology there and some of the methodology for moving around in a space and doing things in that space, especially if it's interacting with you in kind of an entertaining way, it seems to me that there's the germ of a new UI paradigm in there somewhere. I don't know quite what it is yet. And it's certainly not a video game per se, but I think it can build on some of the same technologies.
Well, certainly today we can build our microprocessors with things like the 3D acceleration for free, essentially. So if I know that there was the Insight group here, which I visited a little while ago, and I would really like to see something and utilize the transistors better on the chip for the user interface. And if it's 3D, we can do it for free, essentially. So we're at that point on technology that that's possible.
I think Charles actually identified, if anybody's interested in pursuing it, I'm not in that business myself, but a direction to go in trying to push the interface forward. Look at games. Look at video games.
So I want to see a prototype because we're doing silicon that we need. I'm just shocked there's no university research or no research at all in this area, and I really would like to see a prototype. And I'll give you the hardware if you give me the software prototype.
You gotta do it.
So.
Well, what about all the VR stuff that's going on?
It's a good start.
Go ahead.
Can you talk a little bit about the invention of the Mesa programming language and why you decided to choose Mesa as the language for Pilot and Copilot and Star?
Sure. The question is, how was Mesa invented and why did we decide to use it? The other language alternatives that we had at that time fell into two classes. They were either very superior for quickly building prototypes or even building large elaborate systems, but had the well-known performance difficulties that you would expect with these two very powerful systems we had here, namely Interlisp and Smalltalk. Okay. It was not practical, obviously, to do an implementation in those, although Smith stubbornly continued to prototype in them for as long as he possibly could. The other set of alternatives that was available at that time weren't sufficiently type safe or didn't have the right set of abstractions and so on for building industrial strength software of which you hope to sell hundreds of thousands of copies. So that was primarily BCPL. C even didn't exist at that time, that splendid language embodying the grade given to its designer. It wasn't even here in that moment, so it was BCPL or other very weakly protected machine-oriented languages. So Mesa was actually quite a nice design. It had a few excesses in it that took us a little while to get out, but it gave us tremendous reliability in constructing this elaborate piece of software. And by God, you made a change to things and it started running again the way it was supposed to, and so on. So this was a curious window in the history of programming languages, and the idea of building a big software system that was nevertheless going to be replicated and sold very cheaply, so you couldn't ship a systems engineer with every copy, was really quite new. And that was the reason for the Mesa choice. Peter.
I'd like to just add a little footnote to that. There was a working group at PARC that met a number of times. It was a very high-powered group looking at the requirements for a programming language for the work to be done at PARC itself. And while that group was not directly coupled to the evolution of Mesa and Mesa's follows on, in fact, Mesa had already been developed to a fair point by that time. There were ideas coming directly from PARC as to what a modern system programming language needed that I think influenced Mesa and the choice of Mesa very heavily. For example, the fact that Mesa has a very rich type system and is generally very type safe. This was not a popular point of view for hardcore system programming in the late 1970s and the early 1980s. And I think that it's fair to say that the Mesa artifact, the ideas in it, originated pretty much at PARC.
That's right.
And that it was the apt tool to hand when the star was being programmed.
Yes, over here.
I want to respond to the thing that Charles mentioned about 3D interfaces being a direction to explore. It's amusing to me that the rage in video games right now are 3D multiplayer network games. I recall many years ago Maze War being a very early 3D... You understand?
True. In fact, the fascinating about Maze War, the thing that I appreciated about Maze War was that otherwise I never would have gotten people to be willing to test all that complicated internetworking code. And no, I'm perfectly serious. It was a wretched testing problem, but people playing Maze War absolutely tortured every line of that code, and I was tremendously grateful for that idea. Dick.
In response to the question about why Mesa, Dave Kerber was kind enough to take a paper that I'd written back in '85 and scanned in with Acrobat Capture and put on his website, which doesn't really go all the way back in history to the stuff Peter was talking about, but it has a bibliography that does, and it's a fairly clear description of Tahoe, the state of Tahoe circa 1985. So I don't know if we can make the URL for that available, but
we'll publish that.
I can give another URL.
Go ahead.
If you just go, well, I will have to put it on tonight, but if you go to if you go to www.sweetshop.com, spelled SWEETSHOPPE, that happens to be my a website that my wife gave me when she changed her domain name. I'll put a copy of the paper there.
Cute.
Not a question, just PARC trivia. I believe it is true that the Maze War, all the programmers were playing it all of the time, and of course we were all hackers and we were hacking the sources, and as a result of that, the authors got upset with everyone making cheats, and therefore they stored the sources in an encrypted form on the source tree. And I believe out of all the software innovation that's happening at the park, the maze board sources were the only software stored in encrypted form.
Did the Starship with any hidden Easter eggs that you know of?
The question is, did Star ship with any hidden Easter eggs that I know of? Let me assure you, not any that I knew of. But I wouldn't bet that there weren't any. What else? Okay, thank you very much.